Hello, all listeners. As you all know that we are drowning towards that chapter 7 axially and eccentricity loaded columns. Now, this is our new topic of this chapter and lecture 4 of this chapter. See, static, neutral and unstable equilibrium of column. See, definition of static equilibrium. When a column subject to an axial load P, this P is axial load and is less than the critical load PCR. See this PCR and this P. The column compresses slightly and remains straight after removal of load. Such column is said to be a stable equilibrium. This Roman 1 point is before see this is this 1 and 2 they give us. See from this diagram what we understand that this one is applicable, this one Roman 1 is load application and this Roman 2 is after we remove that load then this is Roman 2. So when a column subject to an axial load P and is less than the critical load PCR, the column compresses slightly. See here, column compresses slightly and remains straight after removal of load. Such column is called as, is said to be stable equilibrium column. So from that stable equilibrium we understand it. P is less than PCR and when we remove this column, when we remove this load, then this column is in its original position. So this is stable equilibrium condition, because see here load is less than critical load, so column does not impacted a lot. That's why this is static equilibrium condition. It depends on a load. See now, see here neutral equilibrium, that means load is little bit increases here. See definition of that neutral equilibrium. When a column subject to an axial load P up to the critical load, see up to critical load, that means it is increases little bit towards up to critical load and the column deforms an application of load. See this column deform on application of load and remains slightly deformed. This word is important. See load increases then column behavior is also changes. This column now are remains slightly deformed position after removal of load. See after removal of load also it is remains slightly deformed and this column is said to be neutral equilibrium. See this Roman 2. This is remains slightly deformed shape. See this H line. After removal of load this is remains slightly deformed. And see this P is equal to PCR. Now in unstable equilibrium, here also load is greater than critical load. So definition of that unstable equilibrium is when a column subject to an axial load P is larger or greater than the critical load. The column deforms more due to axial load and deformation increases as the load increases. Such column is said to be unstable equilibrium. So here load increases and greater than critical load, so due to that column failed. So this is unstable equilibrium. So always remember that relation between that critical and our applied load. So depends on that these three conditions are happen: unstable equilibrium, stable neutral equilibrium and static equilibrium. Static equilibrium, that means axial load is less than critical load, that means it is static equilibrium. P is less than PCR, it is static equilibrium. And second is neutral equilibrium, that means axial load is equal to critical load, P is equal to PCR. And third is unstable equilibrium, axial load is greater than critical load. So it depends on applied load. Okay, so this is it. Thank you very much.